Good morning, good afternoon, good evening, and welcome to another edition of the Level Up Hour. I am Chris Short, executive producer of OpenShift TV. I am joined by two wonderful Red Hatters, the illustrious Langdon White and the always brilliant Dan Walsh. Welcome, both of you. Langdon, I'll let you take it away from here if you want.
Sure. We are here with Mr. Walsh, or as self-referred to as Mr. SELinux, and we all know that to be true. As always, I like to introduce the show just a little bit, just kind of say what we're doing here and why, and maybe share some slides. But so this, in case you are lost, is the Level Up Hour, and we'll see if everything is laid out correctly. So the Level Up Hour here, we talk about kind of containers for everyday usage. Why you as a systems operator, or a Linux sysadmin, or an OpenShift operator, or whatever kind of role you have, not just developers. Developers are welcome too. I come from a pretty strong development background too, but I think the use case for developers using containers is been pretty well made in a lot of places. I use containers for all sorts of stuff all the time, so that's kind of what we talk about on the show. That kind of gives us a little introduction to the show. You can find myself on Twitter at Langdon with a 1, and Chris Short at Chris Short. And actually Dan's Twitter handle is rhatdan if you want to follow him on Twitter. We're always also available to kind of chat, most of the time we're awake, on our Discord, which you can see the link there. But I bet Chris is going to use his magic restream
right now. Yeah, you know it.
To share it in the channel, so that you can go and check it out and join us there. Little bit from, kind of a little bit more introduction. We have the show notes from last time are at that URL, which I will throw in the chat with some fancy clicking. Look at all that copy pasting that I didn't screw
Look at you. I'm so proud of you.
So today we want to talk about SELinux, containers, and OpenShift, and that's why we asked Mr. Walsh to join us, because he knows stuff. And so I don't know. So I think that's where we'll stop with the slides, because we don't want to give away the internet points quite yet. And Dan, if you are unaware of what the sweet internet points are, we will talk about them later. Yes. So as I sip my coffee, first up, we usually try to do some announcements, and so. I know myself and Dan are both giving talks this weekend at DevConf CZ. It starts on Thursday, ends on Saturday. I don't think there's anything on Sunday. And so, Dan, you want to tell us a little bit about what you're talking about this weekend?
Yeah, I have two. One is a BOF, so I run a containers BOF every year, and this is on Thursday. You'll have to look at the schedule. I think it's around 9:30 Eastern Standard Time, whatever that is in CET. And it's basically just a conversation that we have every year, just get together people, talk a little bit about what's going on in the container world, and then try to get, answer people's questions. Try to get as many people from, by the way, I'm the chief architect of all containers at Red Hat. So I bring my team and get them on and get them talking about different stuff. Usually we talk about futures at it. And then on...
Well, I will say, unlike your normal BOF or whatever, that BOF usually is like 100 people, right? 200 people. Like, it's packed, and there's lots of stuff, and it usually runs way over.
It's like flocks of a feather, not birds of a feather.
Exactly. So it is highly recommended, especially if you're doing something kind of esoteric with containers. It is a lot of good discussion there. Unfortunately, we will not be serving beer this year because it's hard to deliver. But please join the virtual BOF at least.
Yeah. And then I have a talk on Saturday morning. Believe it or not, it's 6:30 a.m. I just love this pandemic. Since it's a European conference, it's rather early in the U.S.
Right.
But that talk is just basically looking at sort of like a year in review of Podman. And the talk is talking about all the new features that have gone into Podman. We'll be talking about some of them probably in the next hour. But basically, it's going to be going through lots of demos and just showing you all the cool stuff that's this past year in Podman has been incredible. And we just released Podman 3.0 this past week. So.
Yeah, we're pretty excited about it on the show, actually, because we talk about Podman all the time, and I complain about it, and then I go file bugs, and then sometimes they get fixed, sometimes they get closed, and I'm told I'm an idiot, but whichever works. I'll just pitch. I'm actually hosting a keynote of some student research that's going on around understanding. Sorry, we got some spam in the chat.
Sorry.
We basically looking at microservice architectures and trying to understand what's actually going on in them. It's this open source project called Profit. So that's at 8 a.m. on Friday. And then my talk is at 9:30 a.m. on Friday, talking about event-driven architecture, really using service mesh, serverless. I'm going to try to work in some demos. I didn't realize how short the talks are this year, so I may be doing less demos than I expected. It's probably better because doing virtual talks that are long is rough to watch. But Chris,
like how short? Like 20 minutes?
Yeah, 20 minutes. I was thinking it was more like 30, 35, and but so I'm gonna 20
minutes is tight.
That's tight. Yeah. So that should be good. There's lots and lots of other stuff. Obviously, we can't highlight too much of it here, but I threw the link to the website, which has a link to the schedule. It's free. It's virtual. It is on Central European time. So, if you're on Eastern, you're going to miss a bunch. But if you're in Europe, which I know some of our audience members are, or in Asia, parts of Asia, maybe the time zone will work out better. So definitely recommend that. The other thing we were going to talk about was Container Plumbers Conference.
Yes.
Right.
Container plumbing, or I'm sorry, containers.
It's called Container Plumbing Day, Plumbers Day, so something like that. It's at containersplumbing.org. So this all came about a little while ago. We had some ability at Red Hat to basically throw together a virtual conference, and it was brought up to me to do this, and a couple of conferences I love to go to. It used to be the Plumbers Conference in Linux, which would talk about sort of the low level stuff in the operating system and booting up. And another one is All Systems Go, which used to be the System D conference. But basically that was talking about things like System D and new features of the operating system, but basically all low level parts of the operating system. And so when this conference suggestion came to me, I said, why don't we do a low level containers plumbing conference? I want to avoid Kubernetes, OpenShift, and all the high level, orchestrators and stuff like that, but really talk about what's happening at the operating system level to make containers better. There's lots of changes in the file systems. There's lots of changes in System D, lots of change features being added, and so our goal was to really get a deep low-level look at some of those core technologies for running containers. And that's really what the conference that conference is guided to. It's the first time we've done it. We've got a whole bunch of people submitted talks, and now we're going through the painful process of figuring out which talks to have at it. And that's,
so,
I guess,
to be clear, the Container Plumbers Day is 2 days, March 9th. 2 days. Yes, so much like the Level Up Hour. It's not exactly how it's advertised on the tin. The one of the things I always found interesting about the Linux Plumbers Conference, right? So basically the kind of software engineers that drive, 80% of the low level internet, let's say, always a conference that is kind of done on somewhat of a shoestring budget. So, for example, it was held in New Orleans during hurricane season a couple of years ago. And I was like, that whole VP rule of like you can't put two VPs on a plane together. Let's put all of our top kernel developers in one place during hurricane season and just see what happens. Yeah, sometimes I wonder about the choices we make, but so I actually think that'll be really interesting. Like I think a lot of people don't realize is like we've had some pretty like some stuff that could have landed in the Linux kind of kernel a long time ago but has really been driven by containers, right? So like overlay file systems, or like the concept of them being in the kernel level really didn't materialize until containers started pushing them into the kernel. And so I'm not sure what's our current favorite kind of what's the current choice for the overlay file system? I know it's not, or is it overlay OFS? No, right?
Yeah, so overlay. So right now, I mean, to give you an idea of what's going to be talked about at the conference, going back, overlay file system is the thing that almost everybody uses for containers in the world right now. And one of the interesting things with the Podman effort is Podman is rootless containers, right? So basically allowing you to do containers as rootless. One issue that's always been in the Linux kernel is controlling who's able to mount file systems. And with the advent of user namespace, which what Podman takes advantage of in running rootless containers, there's certain file systems that are allowed to be mounted by inside of user namespace. So you can't mount physical file systems, you can't mount NFS, you can't mount lots and lots of file systems, even if you're in user namespace. But inside of user namespace, you're able to mount the sysfs, procfs, /tepfs, bind mounts, and fuse file systems. So over the last few years, we've been using fuse overlay. So basically one of the guys on my team, Giuseppe Scriban, rewrote the overlay file systems from the kernel as a fuse file system. And that's what everybody in the world, in rootless world, is taking advantage for containers running. The problem with that is the user-based file system is going to be a lot slower than a kernel-based one. And so I've been talking to the kernel file system guys at Red Hat and pushing them. Most of the overlay guys actually work for Red Hat, and to figure out why we can't mount an overlay file system is what we call rootless mode inside of user namespace. And as of the 4.11 kernel, you will be able to do that. And so we'll be demonstrating and talking about how we get things in the kernel to, again, as you just said, to support new security features or new features of the operating system. Now we're going to continue, give you another idea. One of the issues we have with rootless containers is using NFS as a home directory. This comes out with enterprise customers more than non-enterprise customers. So because of that, we have to add lots and lots of support and looking at different ways. How can we get NFS home directories to work in our environment? I don't want to get too deep into it, but basically, when you're running a container in your home directory, you actually get allocated multiple UIDs to run your processes. So just imagine you're doing a pull of an image. So when I pull down an image, that image is going to have multiple UIDs inside of it. So you can have a UID of most of the files say are owned by root inside of your image, but say you have one that's owned by the Apache user, say the Apache user is 60. So when I'm pulling down an image into my home directory, what's happening is I have a process running as my user, Dan Walsh, but inside of user namespace, so it looks like UID 0. And when it's pulling down the 0 files, it's writing them to disk, and everything's fine. It's just basically writing out my UID to disk. But now it pulls down the Apache file, and it pulls it down, and the next thing it does inside of the tar, expanding tar thing, is to chown it to UID 60 inside of the user namespace. So that sounds all good, and that all works really well on a Linux operating system with user namespace because you're allocated a group of UIDs to user namespace. Now let's look at this from the NFS server side. So you're doing this inside of your home directory, and what the NFS server sees my UID, say my UID is 1,000, it says 1,000, writing 1,000 files. And all of a sudden it downloads a file, instead of writing it 1,000, it writes it as 100,060.
Right.
And the NFS server basically comes along and says, no, that's not allowed. UIDs are not able to chown to non-UIDs, because NFS doesn't know about user namespace. And so therefore it denies it, and everything blows up, which causes anybody that's trying to run our containers, Podman and Builder and all the container tools as rootless, won't work on if you have an NFS home directory. And it turns out lots of enterprise customers still use NFS home directories. So we have a issue. So one of the things we're looking at going forward is how do we get continue potentially use the Fuse overlay file system, and have Fuse overlay, our Fuse overlay file system sort of fake out that it's writing out UID 100,060, but basically using extended attribute to write out a file. And so that's the type of stuff we're investigating and working on all the time to solve these sort of tricky issues that don't really exist when you're running rootful containers. But it's how do we continue to improve our security by allowing more and more workloads to run in rootless mode.
So it's actually really interesting that you bring up that example, because I suspect that we actually ran into that exact problem on the show, because I use NFS mounted projects directories from in my home network, and I discovered that if I tried to run a container with control or with :Z, if where the files were for that container were NFS mounted into my computer, it wouldn't work. And I wouldn't be able to have the right kind of write access from inside the container. But if I dropped the :Z, it did work, right? Because I think it was just passing it through. But if I did the reverse and ran it all local, if I needed the :Z. So it was really interesting about how it switched depending on that kind of writing solutions.
It's funny because NFS has been around since I was a young pup, so it's been around since I don't know the 70s or something, and or 80s at least. And NFS moves glacially slow as far as adopting new features, and a lot of that's just because there's a huge installed base, and trying to get these things updated is incredibly slow. So talking about SELinux labels, we worked to get SELinux labels to work on NFS for, it took 6 or 7 years. And even to this day, as you see, NFS, basically NFS is denying you the ability to create those labels. And that's all because you're not using a recent enough NFS server. You probably need NFS version 4.1 on both the client and the server, and they have to be set up in such a way to get XADDRs to work, to get the SELinux labels to work across it. So there's NFS is a constant pain, and even as we, as I talk about the new features that we're trying to get into NFS, because it's a client-server operation, we have to get both the client and server. And in the enterprise worlds, the servers are usually owned by companies like NetApp and other big companies. And so we have to figure out when they're going to have a more recent enough Linux kernel that we can start to take advantage of this stuff. But
we get some of that static in RHEL, as I recall, as well. One thing enterprise software doesn't like to do is change. Is with usually good reason. Chris, did I see it?
Narendev says that NFS is vintage.
but not in the cool shirt sort of way.
Right. In the wine you shouldn't have made vintage kind of way.
But NFS is, we're picking on NFS now, but I would think if you were doing this with Lustre or Zephyr or any of the network-based file systems, you're going to have similar issues. Because again, user namespace is sort of a new feature, even though we look at it as being 5 or 6 years old. It's just the servers don't understand that, this user has actually got allocation of all these UIDs, and that communications is not going back and before.
Well, I mean, yeah, and it's like it's fundamentally wrong, right? I mean, like, you know, like a user should have a user ID, not a set of them, hence user ID.
Exactly.
So, you know, I could see why it would take a while for, you know, kind of the rest of the software to kind of respond to that. You know, like that's a pretty you know, conceptual change to your, you know, your software. Did I see some other questions go by, or
not really questions, just kind of statements.
Okay, that's cool.
Kind of digging through. If you did ask a question and I missed it, please just re-ask it and I will get it caught. But I don't see any necessary questions, just more comments on NFS v3 versus v4.
Right.
etcd needs faster disks than what NFS can really provide, so I dropped a link to that etcd FIO article from IBM that really kind of saved my butt when I was standing up my cluster here at home. So yeah.
So I mean, I think long story short though is that if this conversation is interesting and you want to kind of really delve into it, you should definitely check out the Container Plumbers Day, right? I mean,
Absolutely.
like this is the kind of conversation that's taking place there, and it would be real. Like, you know, I am now more convinced to want to go because I do like some of this stuff. Kind of talking about, let's back up a little bit, you know, kind of moving a little bit higher up the stack. My biggest question about Podman v3 is what made it 3? Like what is it that triggered
what are the
going from 2 to 3 versus just another minor revision?
So one of the things we're trying to follow is what's semantic versioning. And with semantic versioning, the way semantic versioning is supposed to work, this is a Golang thing. So if you think about your version of a product, you have an X, a Y, and a Z. And with semantic versioning, if the Y and the Z change, then you theoretically everybody should be able to upgrade and there's no breakage. So existing tooling should always work. If the X changes, that means that, you know, there's a breaking change, right? That's something, we're going to break something in previous versions.
By way of example, not PHP, for example, which does breaking changes on the Y version just for entertainment value. Yes.
Right. So we had when Podman was first started out, we decided it's the first remote client, remote capability in Podman was, we used a tool called Vilink. And Vilink was the a mechanism for us to be able to start sort of remote containers. And we have Podman on a Mac, and it could talk Vilink to a Linux server, and it would talk to a on-demand Podman instance on there and launch it. And so we were sort of the cutting edge with Vilink, and but we ended up having a lot of issues with Vilink. Simultaneously with this, a lot of people were trying to push Podman to, you know, Podman was originally announced as a replacement for Docker at the CLI level, at the command line. And a lot of people said, well, we need Podman to support the ability to you know, do Docker type stuff, basically implement the Docker socket. So we looked a year ago at our, a little over a year ago at our implementation, and we decided that rather having 2 remote APIs, that we would move to what we call the Docker API, or we call it API v2. And basically in compatibility mode, we implemented the Docker API so that you can actually use the Docker client and talk to Podman and have Podman launch containers for it. But now we can support things like Docker PY, the Python bindings, and the big announcement for this past week is that we can now support Docker Compose, which talks to the remotely the socket. Other things we can cover now, lots and lots of people built into the CI/CD systems, you know, basically tools that talk to the Docker socket. And now we can just put Podman in there listening at the socket and implement it. So since we wanted to go to one remote API, we were dropping Vilink as support. So one of the main drivers for going to 3.0 versus 2.0 was that we were going to drop Vilink. So that was going to be a breaking change for anybody that was relying on the Vilink API and move to this. But we added untold amounts of new features. And probably the biggest announcement is Compose. And we've gotten a ton of people that are interested in a shocking number of people who love the Compose language for running containers locally. But also, again, having support for Docker PY. We also have sort of all the extended features in our extended remote API. So you can do things like create pods and do all of the fancy, closer to Kubernetes type stuff with Podman using the traditional API. So we have, really, that's probably the biggest features in Podman. We have much greater network support now, so that you can do rootless networking. You can set up additional network branches. You can do Mac VLANs. You can do pretty much. We consider ourselves as close to compatibility with everything you can do in Docker right now at this point. So one of our goals was to help our customers, Red Hat customers, move from RHEL 7 to RHEL 8, and in RHEL 7 we supported Docker. In RHEL 8 we don't support Docker, so we needed to have the features. So Podman 3.0, which will be released in RHEL 8.4, has all the features to allow our customers to easily move their existing bases into RHEL 8 without having Docker available. And that's sort of our goal. So right now we're saying when I say we're compatible, sometimes I get in trouble for this because there's certain things in Docker that we'll never implement, like Docker Swarm.
Right. Yeah.
Of course. And there's features that also they've Docker had this thing called Link, where they allow you to link multiple containers together. Well, they've deprecated that, so we didn't implement it. So there's things like that, and our goal now is to take it beyond. Take it way beyond what Docker had capabilities to do. And we've already driven that through our support for originally C groups v2. Speaking of DevConf 2 years ago at DevConf, I announced that Fedora was going to move to C groups v2, even though Docker will run on it, and that caused a little bit of a stink in the world. And I'm happy to pronounce that 2 years later, pretty much the whole world is moving to C groups v2. Docker works on C groups v2 now, and Kubernetes, I think, either in the summer release or the fall release, is going to finally support C groups v2. And it was all driven by pushing Fedora to turn it on by default.
Well, this is we have the Fedora Fs, right? I mean, this is the problem with the first one,
right? But it was, I think Fedora did, it was awesome that we were able to finally move, because we were in a chicken and the egg situation forever, where the kernel guys wanted C groups v2 and the container world was stuck in C groups v1, and it needed a nudge or a shove off a cliff or whatever to finally force us through. And Podman was the solution to this, because Podman worked instantaneously with C groups v2, and we gave people a way to move forward. And Red Hat, a lot of engineers on my extended team worked on making Docker run with C groups v2, and obviously Kubernetes. That's sort of where we also concentrate, because we had to get them to C groups v2. And so those are all the great features that have come in Podman 3.0.
In a few weeks, I can't remember the date off the top of my head, but in a few weeks, we're actually going to have Brent Bowdy on the show to talk about it kind of some more in detail as well. I think I'm going to try to get Urvashi Mahana.
Yeah.
I can never say her last name. But who is one of the co-chairs of DevConf US, but is also a contributor to Podman. So we think she may also be on the show. I have to finish twisting her arm to be on the show with Brent, but we'll see. So let's see. What I did want to talk about, kind of we've been talking a lot about kind of the general world of containers, but I'm kind of curious about, like, what do you see as like what is OpenShift and Kubernetes, in a sense, what is its relationship to kind of security? And when I mean that, like, where does that security come from? Is it coming from Linux? Is it coming from the containers? Is it coming from Run C? Is it coming from something else? Is it a combination of all of them? Like, how does that stuff kind of work?
Okay, so security comes, especially in something like OpenShift or Kubernetes, it comes at different levels. And obviously, things like role-based access control at the, who's allowed to launch what kind of containers and what kind of systems. And that's all stuff that's way above my head. So I don't deal in that level because that's sort of APIs and stuff like that. I deal at the operating system level. So I'm actually looking at how do we control what containers can do, what the processes that are in containers can do at the operating system level. And what we try to do is take advantage of as many features of the operating system as possible to guarantee the separation, right? That we don't have privileged escalation and ability to break out. And these separations are controlled in lots and lots of different features. And I tend to look at sort of breaking the operating system into different features of the operating system. Most people understand root's able to do stuff and non-root's not able to do stuff. So OpenShift out of the box runs all containers as non-root, right? And you have to set special flags to run containers as non-root. So that's sort of relying on sort of the traditional mini computer design from Unix that originally developed, so time sharing systems. But basically that's proven to be a very good security mechanism that you run each one of the containers with different UIDs and then you get a decent amount of separation. But certain times you have to run with some root capabilities, and root also has the ability for basically root was divided into a thing called Linux capabilities many years ago, and sometimes we'll give you a little bit of root, but we won't give you full root. And so the amount of root that your root running containers can get, or amounts of capabilities, Linux Docker actually sort of standardized on way back when about 14 different capabilities. And so when we looked at this, looked at those capabilities, we said, well, let's examine each one of those. And as we've gone forward, running, I call it containers in production. When you're in Kubernetes world, there's like 4 or 5 of those that I just don't believe you need, and so we've trimmed those off. So we're giving you a little less root than you traditionally did. So another way of looking at containers, or if I'm in a container and I'm a bad guy inside of a container. One of the things I want to do is I want to attack the operating system, right? I want to attack the kernel, see if we can take over the kernel. And so there's mechanisms of attacking the kernel or through file systems. So kernel file systems, things like /sys and /proc and stuff like that. And so one of the things we do in that environment is we basically take those file systems, we mount them as read-only. And so, processes inside of a container need to be able to work with read-only, need to be able to work with /sys and /proc, but they don't need to write to them. So we can, and then with the limited power of root, even though you might be root inside of your container, we take away the ability to mount and unmount. So just those mechanisms. The other thing is certain parts of the file system were never intended to be hidden from users. But what we can do is we can mount dev null over certain types of files in the /sys and /proc, and we can also mount empty directories over some directory structures that most processes don't need. Another thing we do is controlling which devices. So another way to attack the operating system is through kernel devices, and so we limited the amount of devices that your container can see. So you don't see dev SD0 and stuff like that. Lastly, another way you can attack the operating system is through syscalls, and we take advantage of a thing called seccomp to, instead of on a x86-64 machine, there's about 700 or 800 syscalls available to you. And what we do with seccomp rules is we can actually cut down the amount of syscalls that are allowed to your processes down to, say, 300 syscalls. And so now if there's a bug in a Linux kernel that involves a syscall that isn't available in your seccomp table, then you can't use that to take advantage of it. The last one that obviously I've been involved with forever is another way I want to attack your operating system is just to break out into the file system. So inside of a container, you sort of get a small snapshot of a file system, a group of files on the operating system. You don't get the full view of all the files on the operating system. So, but if I'm able to break out of my container, maybe I could get out to the parts of the operating system to be able to read. So if you think of just a time sharing system, right? How often do people have world readable files in their home directory? And if I have two users running, I might be able to read that file in your directory, right? Your home directory.
Right.
You might have your .ssh directory set up too loosely. And if you think about that, there's lots and lots of files all over the operating system that probably you don't intend to be read by other entities. And you especially don't expect them to be written to. So how do you protect the file system? If I'm able to break out of the container and get onto the file system, and the best tool in the world to do that is SELinux. So SELinux is all really about controlling access to the file system. There's lots of other features of SELinux, but in the container world, what we really take advantage of is its ability to protect all the rest of the operating system file systems. So think about, years ago, I did the coloring book where I talk about the cats and the dogs, and SELinux is you define a cat type and a dog type, and then you define cat food and dog food, and we write to Linux kernel that a cat can eat cat food and a dog can eat dog food, and everything else is denied. So if the dog tries to eat the cat food, it's blocked. So if you think about it from a container world, what we do is we define all the containers as being a container type, and we define all the content inside of a container as being a container file type, and we say containers can read and write container file types. Now, if a container breaks out and tries to read Etsy Shadow or tries to break out and read random stuff in other directories on the system, it says, no, you're only allowed, you're a cat, you're only allowed to eat cat food. And so that's one part of SELinux, protects the operating system, the entire file system from it. The second part of SELinux is that not only can we say you're a dog, but we can actually name the dog. So I can say your dog and your Fido, and then this is the dog food for Fido, and then we could block, say another dog named Spot from being able to eat Fido's dog food, and that's is my quick analogy to MCS labeling is. So when we launch containers, we actually pick a random MCS label. Basically, it's a little indicator that names the container, and in SELinux we can label the content similarly, and now we say if a container breaks out, it can't read other containers' data because again, this is the dog Spot can only read the container Spot's content. And so fundamentally, there's no other tool in the world that at the operating system level that protects the file system, and that's where SELinux rules. Now, as we get further into security, one of the things years ago, I did another coloring book where I talked about.
Let me actually interrupt you for a second, Chris. Can you pop the ebook bot command, because the coloring books you're talking about are on that.
Oh, that's
page,
right.
If anybody wants to go check out the coloring books. But sorry, so the other coloring book.
So the other coloring book talked about, it's actually based on the three pigs, and the whole idea there is you have your applications, and the pigs are the analogy, and you're basically choosing where the pig should live. And we talk about difference. Pigs should live. The most secure is going to be on physical different machines, and then you have them living in virtual machines. And virtual machines is like living in a duplex. And then when you get to containers, it's like living in an apartment building or a hotel, and that there's a single point of failure, right? The front desk or the maintenance man, he has the keys to all the apartments. So you have to protect in containers world, that's the kernel. And we talk about those, but one of the things that we talk about there is, there is a big effort to take advantage of virtual machines for separation. And so Kata, which was originally led by Intel, Kata containers are becoming more and more popular, and they're starting to be available inside of Kubernetes and OpenShift, where we can actually take advantage of KVM for separating of our containers. And with KVM separation, it adds the additional feature of instead of getting sort of access to the full kernel, now you only get a small slice, right? So you're only able to talk to the KVM devices of the kernel, and,
Right.
and you're running your own kernel. So it gives you this really nice separation. And this is sort of like we've been relying on for security for the last 15 years in virtual machines on top of KVM. So we can start to run containers, not full operating systems in those, but just individual containers inside of these KVM slices to give us protection. But one of the we talked before this started, one of the interesting things that happens in any type of container is you usually want to be able to write to something, right? You want to write to storage of the operating system. And so this is what's in Docker coined the term volumes, right? So this is volume mounting in. So I'm running a database. I might have an image, say MariaDB, that is the MariaDB executable and all the stuff used to support that. But I actually don't want the database in the container. I want the database stored on local storage. So what I do is, right. So what I do is I volume mount into that in storage. And in this case, we talked earlier about overlay, right? I don't want to have a copy on write file system for my database. I want to have great, the best file system I can. So when I volume mount in content into a container, this is where all of a sudden the security becomes a concern.
Right, because it's going to impact the performance of the database itself,
well,
right?
But it also, now, sort of when I talked about the SELinux and the cats and the dogs, I talked about, everything inside of the container is cat food. But now I've taken something from the operating system and stuck it in the container, and that is not labeled as cat food. So I need a way to basically relabel that content to be, the content that this container can use. And in the SELinux case, that's using there's a special :Z and $Z that I can put on a volume mount to cause the container engine, Docker or Podman, to go out and relabel the content. So now it becomes cat food content, right? Or it becomes the container's content. So that's where SELinux works great in containers until you start volume mounting in. Then you have to start to understand that you're taking some random part of the operating system and saying this is going to be used inside of the container. Well, when we move to virtual machines, just like that, right? A virtual machine container separation, how do I handle volumes, right? And in the case of, when you're running in a virtual machine environment, you have a different kernel than the host kernel. So I can't just use standard bind mounts to take a volume in like we do in traditional containers.
And we can't really do it in KVM anyway.
Right. So so KVM causes issues around that, and it basically ends up being a network-based file system. So I get FS or there's a thing called Plan 9 file system, and there's all these different files.
I know Plan 9.
There's all these different file systems to do that, and so the kernel file system team at Red Hat started working on a thing called VirtIOFS, because most of these network-based file systems are thinking that you're on a separate network.
Right.
But VirtIOFS does.
And 30 years old at a minimum.
Right.
Yeah.
Right.
Yeah.
So VirtIOFS is basically realizing that this is all happening inside the same kernel. Virtual, even though it's a virtual kernel, how can we take advantage of the tight communications path here? And so VirtIOFS is a really cool feature for using things like Kata containers and taking volumes off a disk and putting into it. There's going to be a talk at Containers Plumbing on VirtIOFS. It's really kind of cool to look at that. But as soon as dropping back to SELinux again, as soon as I take that file system, right? So I have VirtIOFS, which is running a little daemon, a fused daemon on a host, and that's communicating with the kernel inside of the container, the KVM separated container, and doing back and forth communications. So we basically opened up this pipe for processes inside the container to communicate indirectly with VirtIOFS daemon running in the host, running as root, most likely on the host. And all of a sudden we've opened up a security hole, right? Or a potential security hole. And, even though KVM separation. So it's sort of like we going back to my duplex analogy earlier, I'm in a virtual machine and the only thing I have is a shared wall of the, that's KVM separating the two. But now I've poked a huge hole through the wall.
Right.
For the two containers to potentially talk to each other. So what do we do with VirtIOFS? We wrap it with SELinux. Basically say, And now, we're protecting again, we have to protect the file system from potential escape. We take advantage of other all the other security features, but anytime we even though we have KVM separation, there ends up being you end up having to poke walls through these better separations. So we end up having to take advantage more and more of the operating system. So that's all features that we're taking advantage of right now in OpenShift and containers and stuff like that. And that's all different parts of the operating system I deal with and work with. One of the big features that we're adding to OpenShift going forward, and we're working hard to get into Kubernetes, is taking advantage of user namespace. So user namespace, again, it's key to Podman. Podman's great because of user namespace. It can do all these really cool things with running containers with different groups of UIDs. And so they're separated again using the traditional UIDs. And when we have a container that requires multiple UIDs or requires something like root inside of a container, user namespace gives us the ability to do that in the most secure way. Well, user namespace has never made it into Kubernetes. Okay.
So I don't think I knew that. Yeah. Okay.
Yeah. So it's just not supported inside of Kubernetes because Kubernetes says, how do I translate from the Kubernetes YAML file down to the runtime that I want to run in a separate user namespace?
Right.
And so there's lots of effort going on. We've actually implemented some advanced features in Cryo now, our container runtime for Kubernetes, to support user namespace, but the Kubernetes
isn't consuming it yet. Yeah.
It can do it. We can do it like a side door. So we can use a thing called attributes. So we can set special attributes to say, I want this thing, but Kubernetes doesn't know what's happening. It's just Cryo underneath the covers is doing it. So we're going through the standards process and go through the Kubernetes teams to get user namespace to be a full first-class citizen in the world of that. And I think that'll be out by the fall. I think we'll have full user namespace features. So we're going to have user namespace, SELinux, KVM separated containers, seconf rules. So this, but the main thing here is, there used to be a conference I go to every year called Defense in Depth. The federal team and military, they're always looking at. You don't have just one wall. You have multiple walls, and you have mines, and you have different types of stuff. So in container security or any type of security, you want to have as many levels of defense as possible, so that the bad guy might get through the first line, but he can't get through the second line.
Right.
So that's why when we talk about containers, it isn't just one thing. It's lots and lots of different parts of the operating system.
One thing that occurred to me while you were talking, which I just kind of wanted to ask you about and see if it was accurate or not, is when you talk about rootful or rootless containers, in a sense, like root almost doesn't really exist in Linux anyway or anymore. Kind of as a because it's really just a set of capabilities that are granted to a particular user, right? So the concern, or at least is it really what we're doing here, is that why a rootful container is a problem if you could just take those capabilities away is because you're going from I have a high level of power and then taking away abilities versus having a low level of power and adding abilities. And so when you do the rootful container, you're extracting privilege, which you may make a mistake on. Whereas if you're taking the rootless container, you're adding privileges, and the mistake will only result in that process suffering, not the system being compromised. Is that a good understanding of kind of why rootful versus rootless is better?
Yes, that's a great way of looking at this. Is it's always harder to, in the SELinux world, I used to, people wanted to have an admin, and they used to say, I want an admin that cannot do this, right? I said, no. You can't define something he can't do. What you have to define is what he can do. And if you start with the assumption, this is a user that can, send a ping message, then that's easy for me. If you say this is a user that he can do everything in the system but can't send a ping message, I can't make that happen, right? Because something else that he's able to do can turn off the security that prevents him sending the ping message. Now, so yeah, that's a good way of thinking of it. But I want to go back to your first assumption. You talked about root full versus rootless. Now, when you talk about Linux capabilities, this is a kernel concept, right? So the kernel is divided out the power of root. These are, treating root like it's a non-root user. But there's a couple other things to realize about a root running process. A root running process running UID with no capabilities at all on the system can still read and write all files owned by root.
Right.
And so fundamentally, you don't want it to be root for that reason, right? So, I might be able to modify the Etsy password file because I'm able to write the Etsy password file without requiring any additional capabilities. Secondarily to that is the kernel has basically said that, I'm lowering the power of root. The problem is anytime you do a process-to-process communication in user space has made huge assumptions about a process on the other end of a Unix domain socket is being owned by UID 0, right? They're not looking, if you look at even systemd, it is not looking at which capabilities the process that's connecting it to it is running at. It just sees the UID equals 0 and says, oh, you're root, so I'm going to allow you to do stuff. And, even if that root had all its capability of the only thing it was allowed to do was do ping. So fundamentally, getting rid of UID 0 has merged itself into the operating system, even though it's not really much different than UID 1000. It's so embedded to the assumptions of the operating system that getting your processes not to be able to be run as UID 0 is critical, even if you eliminate all the capabilities.
Yeah. So I suspected that. I mean, because, like I see it all the time, right? I mean, even if you're writing a bash script that you want to run as root and you want to test for it, you basically look for UID 0. There's no like easy bash command that says, is this person root?
Years ago, there was efforts to allow a process to say on the other end of the connection, what capabilities does he have? So it would be really nice if like when you connect to systemd to do some, start up a service or whatever, if it was able to come to you and say, do you have sysadmin capability? The problem is that's racy, and the kernel developer so there's no way to inside of the single communication to be able to figure out whether or not which capabilities are available to a process on the system. And so every effort in Linux has been torn down by Linus Torvalds because he's not going to allow any racy security assumptions to be built into the operating system. So we're fundamentally blocked from ever getting this feature.
Right.
But that's
I literally just filed a bug against systemd the other day saying it'd be really nice if I was not privileged user, if I did system control, status, some service name, it would assume -- user because I'm not root, right? So why would I be asking about anything else? And and so it's kind of funny because we fundamentally don't really have that understanding, kind of in Linux. It's like you're either 0 or you're not, which, that's the problem with, we could just go write a new operating system and then we could solve, this and many other problems.
If we had the Wayback Machine, we could go back to when Unix was created or when Linux was created and fix all these problems.
Exactly. Chris, we kind of were talking for a long time there. Was there?
Yeah, we've got some questions lined up.
Okay.
Yeah.
Cool.
Yeah. So, is there any major difference between the tool Canico, developed by Google, and Podman? And I think it's more of a Canico discussion there.
Canico is more about building container images,
right?
And the real question that would have been Builder versus Canico is probably the correct thing. So Podman has Podman Build, and Podman Build under the covers is basically Builder code sucked into Podman. So most of the time when people report bugs on Podman Build, we always redirect them to Builder and Builder is. So Builder is a tool. So if I'm going to compare Builder to Canico, Builder and Canico do somewhat similar things, especially when it comes to handling of Docker files. And in Builder's term now, we also support container file, because I want to get the word, the DOCKER adjective out of the world as much as possible. But basically, so the format that Docker files sort of standardized, there's lots of tools out there to be able to build container images, OCI images out of them. And Canonical is one, Builder is one. There's one from OpenSUSE. There's lots and lots of tools to be able to do that. What fundamentally we wanted to do with Builder, so we wanted that support, obviously, because that's the vast majority, but we also wanted to experiment with Builder to be able to create images from scratch without requiring you to build a Docker file. The secondary thing I wanted to do was be able to take advantage of the operating system. So, if you ever see me give a talk on Builder, I talk about, you create a directory, you copy some content into it, you create an image and push it off to a registry, right? There's no reason to have a Docker file to do that if you want. And then, so Builder has all of the sort of the low level intrinsic commands to create a container image without having to go through a Docker file. So you could use bash scripting, or you could use higher level tools. And so Builder,
because you want to bring Rocket back. Yeah.
Right, well, whatever. But I mean, the idea is to be able to build using fundamentally low tools. So in some ways, Builder is sort of like a library, and when we ventured into Podman as a library, and then it's also gone into OpenShift. So any of the OpenShift source image builders and things like that are using Builder under the covers. It's been pulled into Ansible, and lots and lots of people use Builder as a low-level tool, but probably the vast majority are still using it as a mechanism for building Dockerfile, which Kernel is doing the same thing. I mean, bottom line, in all these tools, like, I mean, the other nice feature about Builder is that it integrates with Podman, integrates with Cryo, and it really can. It's sharing all the same content, whereas Canonical is sort of a standalone tool that doesn't work well with other tools. It just has the ability to build images and push it. But I don't really care. If you want to, as long as you're building OCI images, then all these tools can work together. And sometimes this is sort of like saying, when should I use rsync versus using
SCP,
SCP, or right. There's lots of tools to do the exact same thing. It's just each one of these tools is sort of developed for slightly different use cases, and they all can come together and use, as long as the files on the disk or the OCI images of the shared content, then we could all work together and sort of experiment and build up new tooling to do this stuff.
Gotcha. Was there another
There's
question?
Another
Chris,
question.
or?
Yeah. Why did Podman decide not to support Varlink?
So it was two things. Varlink didn't have Varlink hid a lot of stuff from our engineers, and we'd be randomly getting random breakages, and we couldn't understand the low level functions that would go in there. The other thing is Varlink didn't seem to have great upstream support at the time. And lastly, so probably the biggest one is we didn't want to have two ways of doing this. And most people were demanding that we did, an API based on the Docker socket API. And so, it was just like, it just made, at a certain point, it made more sense to us to just move to a RESTful API for our remote communication than embedding another tool in the middle, so that we could just use standard HTTP communications like Docker designed for the Docker socket.
Nice.
So there is literally now a socket as well.
So Podman, you can set up a Podman service with, basically it's a socket. Again, we don't have a daemon, right?
Right. But it's socket activated.
We have a systemd service that when you connect to a certain socket will activate a Podman instance, and that Podman instance will service, will basically launch a container or give you a list of containers or whatever. But basically each one of these communications causes a Podman instance to be fired up and then communicate back over the channel saying, here's my containers, or I created you a container, or I killed your container, stopped your container.
I don't, yeah, for some reason, I don't think I ever realized that the socket communication that Docker was doing was like HTTP kind of REST, socket API, communication. Yeah. I always assumed it was like a loopback kind of binary socket, that was, yeah, that's interesting. Okay. So was there another question or anything, Chris?
One just came in, actually. Can you use Docker Compose with Podman rootless, since Podman can do the socket rootless?
So this is a question you can ask Brent when he comes on in a couple of weeks.
There you go.
But the answer to that is not yet. So again, we were rushing to get the thing out, so we got the full support for Rootful, and no one's ever looked at running Compose rootless because it was always talking to the Docker socket. But since we are the champions of the rootless container, we will make it work. The biggest issue we have right now is Compose does a lot of network configuration when it starts up. So most people don't ever configure and do stuff with the network. Well, Compose does a lot of stuff with configuring the network when it starts up to get two containers to communicate and stuff like that. And a lot of that code doesn't work well with rootless networking at this point. So that's just something we're going to fix. And I would figure that'll be fixed in, say, Podman 3.1 or Podman 3.2.
So I had a question about that.
Brent, ask Brent that one, and I'll tune in and find out what he's saying about that. Yeah, since he did most of the work on Compose.
So one of the things that I actually think was really cool and didn't realize about Podman, before I actually started doing the show, was the basically being able to describe, a pod, like a Kubernetes pod as YAML, and kind of, essentially do the equivalent of Podman Compose, but using YAML that would also be translatable to Kubernetes or OpenShift. Is there a consideration around how, like, what I thought was kind of cool about that is I could, on my local machine, then I could set up, my little database, my little web server, whatever, and kind of set it up all correctly to eventually be deployed in Kubernetes with the same syntax. Going to Docker Compose syntax to kind of semi-accomplish the same goal means I lose that kind of translatableness to Kubernetes. Has the team been thinking at all about what does my migration look like from, okay, now I'm tinkering around with my Docker Compose version of the thing, but now I want to go put it in OpenShift. How do I have to go rewrite it now in YAML in this new language I don't know anything about, or is there a way I can convert, or is that something you thought about yet?
We'll take a step back. So I've been dealing with Docker since Docker started back in 2013, 2012. And I know how to run containers very well at the host level. And I've always been trying to push off going to Kubernetes because I like to live in my little single node host where I'm an expert at. But one of the things when I've gone to the Kubernetes world, it's always like, oh God, I got this YAML file, which basically I go out somewhere and I download someone else's pre-prepared YAML file, and now I go start mucking around with it and failing miserably trying to figure out how to write a container to run inside Kubernetes. So one of the fundamental things we did with Podman, we said, let's sort of build the best practices to running containers into it. And we have a thing called Podman Generate Kube. And what that does is takes your running containers or running pods on your system and takes what those are and translates them into a Kubernetes YAML file.
We did a show about it, in fact.
Right. Yeah. So it's a kind of cool feature. And the secondary thing, we also said, sometimes debugging things in Kubernetes is difficult. So I might want to take my Kubernetes YAML and just run a Podman play cube, which will take a Kubernetes YAML and run it. That's basically what you talked about here. And one of the goals with Podman is to make the roadmap onto OpenShift and Kubernetes easier, right? To allow you to transfer from your sort of Docker knowledge to your Kubernetes knowledge. So reasons interesting, the question you asked about Compose is actually Brent, who's coming up to give a talk with you guys, is also giving a talk at the Containers Plumbing called going from Compose to Kubernetes. And what he does is he uses Compose to generate containers running on his system, and then he uses Podman to generate kube from that, and then he takes the Kubernetes and runs inside of YAML. And so that's the whole workflow that he's been looking at. But the thing is, we can't ignore, Compose probably has, I don't know if it's,
it's great.
Kubernetes, but it's huge.
Yeah.
It's a huge user base that relies on Compose, and tons and tons of big companies have relied on Compose. And as you said, it's very difficult to go from a Compose YAML to a Kubernetes YAML, but using Podman in the middle actually makes it easier to at least get, so sort of like I've never written a piece of code from scratch in my life. It's always something like copying and pasting, right? And so, at least with the Kubernetes generate kube, Podman generate kube, I get to the point where I have a Kubernetes YAML that's, that I can sort of map back to what I understand here. And now I can start looking at deployments and sort of the advanced features of Kubernetes from that point on. So that's our goal. And our goal, when people come up to us, if a person comes up to us and says, we're going to run multiple containers on a single host, I would say write it in Kubernetes YAML to start. And don't.
But you never know that when you're writing the code to begin with, though, right?
But I mean, your goal. The goal is to get. Our goal is to get. Your application to run on thousands of nodes and have it orchestrated around Kubernetes. So your end goal is that. But you might start out with just wanting to run a couple instances of your application on a single node. Then you write it in Kubernetes YAML and just launch it with Podman.
So just kind of on the note of never writing your own code from scratch, I have to plug one of my favorite pieces of software of all time, which is a little Python script called How Do I, which on the command line will actually search Stack Overflow and all that stuff for how do you do this thing that you can cut and paste from. I will throw that in the chat.
I got it.
All right, we both got it. There we go. Because I like to plug it because I think it's awesome. Let's pause there.
I'm actually old enough to remember programming before you had search engines, and we would have you'd have racks of books on the wall, and you'd be pulling them down, and then you would read from here and type in exactly what the example did.
To be clear, I'm old enough to remember Yahoo launching, so not having to guess websites anymore. So that was one of those ones where, in retrospect, you were like, oh, this seems obvious. Why didn't it occur to anybody to make a yellow pages of the internet? All right, so we're pretty much out of time. So I think we should try to hit the points. We try to usually do that within the hour, but
Dan, if you need to jump because it's after 10 a.m., that's fine. We appreciate you coming on and everything. If you want to stick around, that's fine too.
And hear about the
it depends on your schedule.
I'll drop out now. Nice talking to you guys. And
thanks so much for coming.
Any additional questions or anything else? I'll be at DevConf this week and then the conference afterwards. So
thanks, man.
See you guys later. Yep.
Thank you so much. Yeah, appreciate it.
All right, so I will just share
sweet internet points.
First, some sweet internet points. And here we go. Narendev is still slightly on top with Netherlands Hackham right behind him. 4,300 and 4,200 points. That's ridiculously a lot.
So much.
I will point out Noah Friction made a big jump this time. I can't remember exactly what he had before, but he did make a big jump over this notch. And yes, Noah, I'm assuming it's a male. I apologize if I'm incorrect. But then we also have Joe Fuzz and Detective Conan Kudo and Bacon Fork still going strong, starting to catch up. We got to get some more points. We have on the screen right now the way you can get points for this episode, and I'm throwing it in the chat right now. So definitely go out and go after those sweet internet points. And it's definitely neck and neck. Do remember there are other ways to earn points besides just watching the shows. You can file issues on the episodes, with like topic suggestions. You can do PRs. You can, and now, if you remember from last episode, I think I was talking about the OpenShift clients container. A PR against that would also be a PR in the level up hour kind of vein. Yep. So or issues against that, stuff like that. So definitely let us know. I did call out, if my slides work, a couple of new-ish people. Trolling on chat does not gain points.
No,
there is too much self-benefit for the trolling that you are not. There's no external reward as well, I'm sorry to say. But we do have 3 new people that I saw. There may be others, and I just didn't realize they were all new. But so thank you, and I hope you're back from last time. And I don't know, Walker, Triple Dub Walker, maybe. And DJ Folo and Alex77G. Well, wait, 7 would be Leet, would be L, so no, still not pronounceable. Nope. So yeah, I got it. Thanks so much for coming. I hope you are back this time. I hope you come and watch more shows. We have a pretty solid schedule, I think, out through May. We're doing subscriptions and licensing, I think, next time. Oh, actually, good note. We are dark next week because I will be in a weird time zone, even though I will be at home. So we're not going to do the show next week, but the week after that, I think we're talking about subscriptions. And
we're
licenses
bringing an
or
expert on to talk about subscriptions.
Exactly. And actually we have a couple of experts and maybe some more because it takes a large number of experts. So we're going to talk about subscriptions next time. I think we're going to talk about Helm the one after that, and then after that we're going to have, that's when Brent is on, and that will be talking about Podman v3 in particular, and maybe some deep dive stuff into the compose components. Then after that, we actually are going to be doing another doing a deep dive into UBI and what's involved in UBI, and then actually right after that, we're going to be talking about Summit, and at least Summit, maybe KubeCon as well, with Chris Wright, the Red Hat CTO. That's coming up in, let's see, what's the date for that? Looks like April 21st. So about a month from now. Or no, 2 months from now. Oh my goodness, it's only February.
It's only February.
It's only February.
When you start thinking in ahead, like I live in the future, right? Planning shows and everything. I forget which month it is sometimes. I've been talking to a bunch of people lately about like there's various kind of people involved in the Red Hat ecosystem, so like partners, customers, casual users, whatever. But a lot of them, they like feeling like insiders, with kind of like insider knowledge and stuff like that. And I'm like, are they watching the OpenShift stream, the OpenShift TV? Because that's where you get knowledge of the future. So definitely, thanks so much for coming. I hope you enjoyed the show. I hope we weren't, if that wasn't what you wanted to talk about with containers and security and that kind of stuff, let us know either on Discord or file an issue or whatever, and let us know what other aspects of security you'd like to talk about or hear about, and we can either invite Dan back or we could invite others to discuss those things. We're here for you. Yeah, indeed. And coming up next on the channel at 11 a.m. Eastern, 1600 UTC, is the OpenShift Administrator Office Hour with, we're got a guest, Christian Hernandez is going to come on, and we're going to talk about Windows containers and getting those working in your environments, because that has been a huge request of ours, and Christian has been hard at work making it all work good. So if you're interested in gaming and building games, coworker, team lead, manager type, whatever you want to call them, Eric Jacobs is doing the scalable multiplayer game design with OpenShift.
You forgot C coder.
Yeah, C coder. Yeah. Or C++ even. the show is all about how to scale out like a multiplayer game. So just check it out. I always find it interesting, right? Like I actually tune in to watch it, even though I have like zero involvement in it, because it's just amazingly great. Cool. Yeah, thank you, Langna, for dropping that in there.
Somebody just asked where they file an issue if they want to talk about like some future show or something. If you file an issue on the episode's repo, I will be most likely to see it. You can also, if we don't for some reason, hassle us in Discord.
Yeah. So Dezintar's just said, just recently failed to test molecule roles in Podman, which requires to set some SELinux booleans. Haven't seen that before.
It happens. I mean,
Yeah.
usually you have to set SELinux booleans sometimes. I certainly don't know how often. But that is interesting. Feel free to bring that back for when Brent's on, and maybe he can talk about it a little bit more. Let us know.
Yeah. So yeah, let's wrap this thing up and send it home. Definitely check out the developer sandbox if you haven't used OpenShift before, or if you have and you want to learn a little bit more, right? We've got free developer sandboxes we're handing out. It's in beta. So it's kind of resource constrained, but we have seen it stand up. What was it? We stood up our server.
I did the Nextcloud thing in there.
Yeah.
I was fooling around with it.
The
other thing to keep in mind, CRW are the code ready workspaces is also in there.
Yes.
So you can do kind of like online IDE inside the same environment that you're actually going to deploy the thing that you're playing with or building directly into the same kind of environment. So it's kind of one big integrative environment of here is a text editor that looks like VS Code, and it will deploy an application directly into the containers running inside OpenShift.
Yep.
It's pretty slick.
It's awesome. So definitely check that out.
And the amount of noise internally about trying to get more and more capability in there is very high.
Yeah,
so
very high.
So expect more.
Like expect more in the future, right? Like it just launched last week. I mean,
so pretty recent.
Yeah. So yeah. Regardless, check out the show later today. Subscribe to the calendar, and we appreciate you tuning in. And we want you to stay as safe as possible out there and
drink more coffee.
Drink more coffee, because Lord knows I need it.
I know, mine's gone.
Oh, sad. So sad. All right, folks. Thank you very much. Well, see you next time.